Hey everybody, whoa. What's going on everybody? Gerry in the lab here today, again, as always, right? So today's video, we're gonna be building a custom adapter for my Data I/O Labsite Universal programmer. We're gonna be adding some IDC connectors. This is what one of the official ones from Data I/O looks like. We're gonna be adding some IDC connectors to this in order to perform some logical scans when we run an array sequence to re-enable an Altera MAX 7000S CPLD that's in a state of JTAG Lockout. If we can replicate this array sequence, it's going to allow us to build a very simple circuit to reactivate and re-enable the JTAG interface on these locked devices. So that's today's video. We're going to be building this custom adapter. So let's dive in. Here we go. Bring this, get a better angle here so you guys can see the state of the bench. As always, a disaster. So, no choice. Gotta clean it. Okay, so here's our circuit. We're actually going to be tearing this circuit down and we're going to be salvaging this PLCC socket that I used here, and I'm going to be removing all these interface connections, and we're going to build a adapter for the PPI base module of my Labsite programmer. So this is a special base unit that accommodates different PCBs. And as you can see, it's got various pins here for interfacing to these adapters. And so now for our adapter that we're going to be building, we're going to be using a special board that I got off eBay. And this is the board here. And this was built by a member in the community, and he has been selling these on eBay. And so essentially it allows you to just build your own custom adapters. And so you can just make the necessary wiring connections using tie lines to the various interface pins, which the community have been actually reverse engineering and mapping for different adapters that exist. And so there's an archive online for that over at the Data I/O EPROM group on Groups.io. I'll put a link to that group in the description for those of you that are interested in checking that out and seeing what existing adapters they have on file. So what we're going to do now is we're going to disassemble this circuit, and I'm going to desolder everything here and just tear down, and then we'll jump over and start soldering up our adapter for the PPI base. So enough talking, let's dive in. All right, so we've got the PLCC 84-pin socket ready to go. All the connections have been unsoldered, and we have the board here ready to go. So I downloaded an Excel document from the Data.io EPROM group, and this is essentially the document that people use when they're making the interconnections of existing boards, sort of reverse engineering the pinouts for a board or an adapter that's that you might have in your collection and that they don't have archived. So you download this, print it out, and then you just pin out these interconnections using a multimeter, a continuity tester, and then you map out all those connections between rows A, B, C, and D, right, on the board. You match up those interconnections to all the pins on the socket with the adapter that you have in your collection and that you're mapping out for the community to use and reference, and then potentially build your own adapter or a version of that adapter that was archived. And so now this here, what I've done here, this is the pinout interconnections for an 84-pin PLCC socket adapter. And so I'm going to be using this in these interconnections here to build our adapter. Now what I'm going to be doing is I'm going to be making those interconnections to a series of these IDC headers that I'm going to mount here on the board. So just to make sure I have enough real estate for the adapter and the IDC headers, I'll likely place the headers like this and maybe a couple on the side here, and then I'll just mount my socket down in the corner here on the board, and then I'll just make all the interconnections on the back, just like on a perf board. So that's the plan, and once that's done, I'll have access to the interconnections here to connect to my logic analyzer, and as well as the Agilent multimeter for doing voltage sweep tests. So I'm going to dive in and solder this together. Don't forget, people, merch page. Get your capacitor mugs. They are fantastic. All right, back to it. This hobby, you have to be very, very patient, but I love the meticulous work. It's, I don't know, it's very calming. And I just really, really enjoy it. And I've always loved it as a kid. You know, doing some soldering work or any kind of rework of any kind on a board. So much fun. Again, I guess it's just like relaxing. I don't know what it is. You know, it's like, almost like gardening, you know, people that do gardening, you know, and I've done gardening as well, but it's the same kind of just relaxing, you know, you're just very calm and chill. I don't know, I love it. Oop, I need to change it out. Okay, I'll just confirm here. Just confirming the last connections for VCC and ground, as well as decoupling capacitors. Looks good. Okay, I think this is good. I think we're in a good spot. However, if we'll debug if need be. But I've done the continuity checks, so this should be good to go, I think. We're going to hop over to the Labsite and insert this adapter into the unit, and we'll pop in a 7128 SLC84 device. Okay, so here we go. This is the moment of truth. We're going to hook it up here to the Labsite, and we'll boot up the software. All right, so here we go. Okay, there it is. Lock it in. There we go. All right, so we'll boot up the software now. All right, so it's going through its initialization boot up process. And it's ready to go, so I can go ahead and close that. Select our device, which is the Altera EPM 7120 SLC84 PLCC84. So here we go, moment of truth. If this works, then it's detected the adapter correctly. And that's what we've been waiting for. Amazing. Okay, that's good. Step one, the adapter has been correctly identified. So that's awesome. All right, so now we select our object file, our program object file. And we're doing a disable, which is number 2 here. 7seg DO2, that's fine. Okay, it's loaded. That's amazing. So now I'm going to actually try and erase the device first. So here's our erase menu. So here we go. Okay, we have an error. Hey, girl, shut up. Oh, I didn't insert the I forgot to insert the device. Okay. Oh man, I was kind of discouraged there, but this is awesome. Okay, so there's still hope. Okay, so here we go. There we go. Now I'll just lock it in. There it is. Okay. Moment of truth. Here we go. Oh, there it's going. Hell yeah. Awesome. Okay. Fantastic. Oh man, that feels good. All that work. Okay, so we have a working PLCC 84 pin socket for my Labsite with the additional IDC headers. So that's amazing. So now at this point I've got to rig up a couple more lines to this, but this is awesome. This is a great step in the right direction for interfacing our device. So I'm going to go ahead this week and interface these IDC headers to the chip, because as it stands right now, the only thing that we have hooked up there is the PLCC socket to be able to be programmed. So that's great. So I'm going to move ahead and interface the headers to the supported pins there. And we're going to be able to run some voltage sweep scans as well as some logic scans with my logic analyzer. And then we'll finally be able to start seeing what's going on during an erase sequence. So this is a great first step. Right on. All right, everybody, we got the adapter working. So awesome. Oh man, I was so bummed when we tried to program it initially and then it failed and gave that error, but then I just forgot to put the chip in. So that's it's pretty awesome. I'm super pumped that we got this working, and it's just, you know, the first hurdle in the steps that we're taking to you know, get the data that we need in order to see what's going on with an erase sequence for the Altera MAX 7128 SLC84. So as I mentioned in the next video, we're going to be running some logic scans with the logic analyzer as well as my Agilent multimeter, which I have automated using a Python library called PyVisa. Really awesome, really amazing, and I'll be showing you guys that. And we'll do some voltage sweeps on some of the pins just to see what's going on. And as well, we'll be hooking up my logic analyzer to see what's going on there during an array sequence for the Altera CPLD. So this week I'm going to be busy interfacing the IDC headers to the PLCC socket pins, so that when you guys come back in the next video, we're going to be ready to go and be able to hook up my logic analyzer, and we're going to run some scans. I'm super pumped. So this is awesome, guys. I'm really excited that we got this this done today, and I hope you guys enjoyed the watch. It was a lot of work, but worth it. We got it working. So awesome. All right, everybody, that's today's video. Please hit the like and subscribe if you can. It's always appreciated. And we will see you guys in the next video. Take it easy, and bye for now. Ciao.